Hello everyone, this is Mahyar. I'm here with another tutorial. In this guide, we'll walk through the process of constructing a multi-layer perceptron MLP-based nonlinear regression model in order to predict the median house price using the Boston housing dataset. For this, the first thing is to import necessary packages. Because we're using Colab, we don't need to install Keras, NumPy, or any other packages. We simply can import them. One of the features of Keras package is that there are some publicly available datasets that we can use them through Keras, and one of them is Boston Housing. We only can use this import this data set and we have it. And then the next step is to pre-process the data. We can use load underlying data to load Boston Housing data set. For any machine learning or deep learning projects, we need to have separate test and train data set. We need that test set in order to be completely separate from the training set in order to be able to test and evaluate our model using that data set. So we just split the data set into train and test set like this, and then we need to do some pre-processing step. Like we know that these, if you go through this data set and print it or plot it, you can see that there are lots of features. And we need to make, we need a simple model. So we don't need to all of those features. We're going to go with these features, just select them and just let other features go. We don't need those features for this problem. Another thing is to remove the outliers. Outliers, we can say, for example, if the median price of housing are more than 200,000, if there is a house with price under $50,000, it means that it's outlier. It's an error. So we simply can throw them away by giving this line of code. So we're removing all outliers using that. And the next step is to normalize the data. Normalization is a crucial pre-processing step in machine learning. It involves scaling the data input features so we have similar ranges. This process helps in speeding up the training and leads to faster coverages of our model. So in our case, we start with computing mean and a standard deviation like these two line of code, and then by subtracting mean and dividing by a standard deviation, we will have our data normalized. Step 3 is involved with building our model. So we're using a sequential model. So we need to import a sequential model that is under Keras package. So this model starts with an input layer that matches the number of selected features, and then adds one or more dense layer, or we can say the dense layer as fully connected layers too, with a specific number of neurons. How it's going to work, see, we use here 64 neurons. It's in hyperparameters. You can play with it and see how many neurons you need for this layer. And this is what I said. The first input is the number of features that we have in our input. So this is the input of the first layer, which is a dense layer, and we use ReLU as our activation function. So it used to introduce nonlinearity into the model, allowing the model to learn more complex patterns. And also, I said it's the first dense layer. This is the second dense layer. Again, these neurons, we can play with them. And the output layer, it only have one neuron, because the output should only give us one number. We want, this is, what I have to say, it's, it is a regression model. We are training the model to give us a number. What is the median price house value? After we construct our model, which is here, we need to compile this model. What optimizer we need? Let's say we have a forward propagation and backward propagation. In the backward propagation, how the model, with what optimizer is going to optimize the values. Here we're using this, it's not, you can use ADAM, RMS, or anything. It depends on, it's another hyperparameter. You can play with it as well. And you have to specify the loss function. What is your loss function? Here I'm using MSE, mean square error function. Based on your problem that you have, you can have different loss functions. Here I'm using this, but you can have, there are other loss functions that are available on this Keras package, or you can have custom loss function based on your problem. Also, you need metrics with what kind of metrics you want to check if your model is working well or not. I'm using, again, I'm using mean absolute error, and it's not the only option that you have. You can use accuracy, you can use anything else based on your data set, based on your model, based on your problem again. And then we can using this, we can define the model, and then this is the code that helps you to print the model to see the information and details about the model. Here we can see that the first layer is a dense layer. This is the number of parameters, and this is the second layer, the number of parameters, and then you can see many information. It helps you if about the shape and other things. And then the time to fit the model. We need train and labels. We have to specify the number of epochs. This is another thing that we can consider as hyperparameters. The split validation, we have this split the training set as validation set and training set, and in each epoch it validates the model in each step to see how it's working. And after I train the model, fit the model. It's a start training because the model is small, it's going to be fast. So in each epoch, it trained the model, and test or validate the model using this validation set. You can see we have the validation loss and mean absolute error loss. We need this loss to be as little as possible. We want to make it smaller and smaller. And then the last step is to evaluate our model. Now we have the model here, it's trained. Now by run this code, you can see that the mean absolute error on the test set is 2.8, and this is the mean square error for the test set. It is not the only way to train this model. You can go with and play with the number of layers, number of neurons, with optimizer, loss function, metrics. You can play with many things. Even you can change the number of features here. So this is one way to help you to start with Keras and train your model. I hope this tutorial helps you to start your projects. That's it. Enjoy.